Okay, good afternoon. Today, I want just in the time that we have left, I just want to go over a little bit of the design topic. So specifically designing of an op-amp. In this case, in this class, we are simply looking at op-amps as an off-the-shelf component, right? So we're looking at a very low-level designing. So in a op-amp, we are simply taking a few external components like resistors, capacitors, and we are creating our own circuits. In this class, 113, we are specifically looking at the basic amplifiers, inverting, non-inverting, summing, difference amplifier. When you get to, let's see, EE212, we'll be working with active filters. In 211, you'll work passive filters. 212, circuits 3, you will use op-amps to create active filters, where you can attach capacitors and inductors to create other kinds of circuits. So the design for any system or any component, design for any system means deciding which components you want to use. So in this case, if you're trying to design for a specific amplifier, the primary output is basically a gain. So we need to design the gain of an amplifier. Okay. Again, if you are talking about designing an amplifier, we are simply trying to decide the components that would match the gain, the desired gain for our amplifier. So for instance, if we talk about, let's bring up the notebook. If you're talking about the inverting amplifier, design of an inverting amplifier would need a output goal. The output goal would be the gain of an amplifier. So the requirement would be given, and that's of course how all systems would work. So as an engineer, when you go out and work in the industry, you'll always have a goal in front of you, right? Your team would have a larger goal, your company or your corporation would have a larger goal. So in this case, or in this example, the goal of this amplifier is to obtain a gain of, let's say, 7. Okay, gain of 7. That means we need to choose components that would satisfy the equation that is required to obtain a gain of 7. Does that make sense to everyone? Right? So what is the equation for a inverting amplifier? The gain, the voltage gain AV, is given by minus RF over Rin or Ri. That means the ratio of the feedback resistor RF to the input resistor Ri must give us the value 7, right? Now here's the key point. Theoretical design, we can choose any resistor we want, right? We can choose 1K and 7K, and we can get a gain of 7. We can use 1 ohm and 7 ohms, and we can get a gain of 7. Theoretically, if you try to simulate this in any kind of software, circuit simulation software, it will work. You will obtain an output. Practically speaking, however, that's probably not a good value, because the lower the resistance, the higher the current, right? So if you're attaching a 10-volt power rail and you use a 1 ohm resistor, that's going to give you a large amount of current, which would probably exceed the tolerance, the power tolerance, or the power dissipation capacity of that resistor. Anytime current flows through a circuit, energy is transferred. A lot of the energy is dissipated as heat, is lost as thermal energy. So our devices get hot. That's why every component comes with a power rating. Most resistors that we use have a 1/4 watt power rating. That's 250 milliwatts. Okay. So in a real life design, we would have to take all of these into account. In this theoretical design, we are not taking that into account. Okay, not unless the problem specifies. Since this is the first step, So the first time you're talking about designing, we are going to ignore all of those power limitations, power lines, etc. Okay. Second point. Second point is that resistors are not available in all values. Okay, if you look at your textbook at the back in appendix, one of the appendices at the end, it's either appendix A or B, I can't remember which one. There is a standard set of values that resistors are available from manufacturers. So there's 1, 2.2, 3.3, 4.7, 2, and then 5, 6, and then multiples of those numbers. So multiplied by 10, 100, 1,000, 10,000, 100,000. Okay. So you can get resistors only in those fixed values. So if you want like a 300 ohm resistor, it may or may not be available. Okay. Then you'd have to create a combination using either series or parallel connections. So again, real life design would require you to actually come up with a real life practical value. But theoretical design that we're doing here, we can come up with any value we want. Typically, resistors typical values would be in the kilo ohm range. Okay, and that would give us a safe limit on the currents that are flowing through our circuit. And so if I was to design this using these in mind, I would say choose Ri as 1 kilo ohm and Rf as 7 kilo ohm. And I can get a gain of 7. Okay. Yes. Inverting amplifier. So the minus sign refers to it being inverted. Yeah. All right. Questions? Does that make sense? Again, we are performing theoretical design, not practical. In general, if you read books, most authors will refer to design as a practical, meaning it'll just state, go ahead and design this system, and it would be expected that students know what they're referring to. But for my class specifically, what I'm telling you is we are not looking at that just yet. Okay. So as an engineer, it's up to you to develop the skill of understanding what the question is asking of you. So if you just read the words and it says design, more often than not, it will mean a practical design. But again, in my class, in this class, we're only limiting our discussion to theoretical values, not practical. Okay. So that's 1K and 7K. That gives us a gain of 7. It's a gain of 10. If it's a gain of 11, again, we just take the ratio and ensure that the ratio matches the gain. Okay. So designing an inverting amplifier is as straightforward as that. When it comes to non-inverting amplifier, the gain equation is a bit different. Oh, sorry. So design for a gain of 7. Well, the gain equation for a non-inverting amplifier is 1 plus Rf over Ri. Right? We always work backwards. We have the end goal in front of us, then we work backwards to determine what is needed to reach that end goal. Okay. Non-inverting amplifier, whatever the gain is, always subtract 1. And then you work off the ratio. Right? So Rf over Ri simply be AV, the gain, minus 1. In this case, if you want a gain of 7, then the ratio of the feedback resistor to the input resistor would be 6. You had a question? Okay. So again, non-inverting amplifier, it's 1 plus RF over RI. So the gain equation ratio of the two resistors will always be the gain minus 1. In this case, if you're if you're creating a non-inverting amplifier, then the ratio needs to be 1. So we can choose Ri to be 1K, then RF is, what is RF? 6K, right? Same gain, different amplifier, inverting versus non-inverting, but different resistor values. Okay. So again, as an engineer, and this goes for like any system, you have a goal in front of you and you would have certain resources available to you. Whether you're a student, whether you're a working engineer from a few years from now, you'll have an end goal and you'll have a few resources. So you always design your system keeping those resources in mind. Again, if all you have are 100 ohm resistors, it is still possible to create 1,000 ohm resistors and 6,000 ohm resistors. Depends on how many you have and how much space you have, right? Otherwise, you can alternatively find simply a gain using any value of resistors. If you have 100 ohm resistors, you can use, let's say, 200 or 300 ohms for your RI, and maybe 2100 or 1800 for your RF, and it'll probably still work. Okay. All right, questions. 358. Any questions? Okay. All right, so there's one. There's one more, and it has to do with the power supply rails. Okay. But since you are all in a rush to get going, let's end class here today, and we'll pick up here again on Wednesday. Can enjoy the 1 minute and 15 seconds. Oh, I will post a homework later tonight based on the inverting, non-inverting. So once I do that, I'll also post an announcement. So please check the Canvas for announcements.